Welcome, class. Welcome to yet another day of school, another day of chemistry. I hope you're having a fantastic day. Today is Thursday, and we are going to be exploring dimensional analysis and doing a quick review from yesterday. So let's get ready to rumble, people. Okay, so whoops, I pushed the wrong button. So there we go. Let's keep going. Okay, so this is just a quick review. I may pause the tape and have you do this in your groups real quick, but how big are the metric prefixes and where do I find information on this? And from yesterday's video, we gave you this awesome thing, which has all the ones, and pretty much what you need to know is you need to know from tera all the way down to pico and what these values mean. And so we'll talk a little bit about scientific notation, how it is in our lab groups or in our classroom. So here is the stuff. Ready? So let's do this. So take a moment and figure out if you can find the largest to smallest order on these things. Ready, go. Okay, so the biggest, tera is the biggest, so that would be from biggest to smallest. So we're going to go T is first, followed by G, because that's a giga, that's 10 to the ninth, that's billion, followed by big M. Big M is mega. Okay, so that's 10 to the sixth. Kilo is 10 to the third. Okay, then we got, let's see, we got deci, followed by milli, followed by nano, and I think that's all of them. So that's how you can kind of know, and you kind of have to memorize them because then that makes everything super easy when you convert in chemistry. And in the SI system is used all around the world, so Okay, so there's that chart. You guys can work on that. Remember the base units from yesterday, all that kind of stuff too. Okay, now, today everything is about using dimensional analysis, using something called a conversion factor. So conversion factors by definition are things that are actually equal to other things. So if, for example, if I have 12 inches, I literally have 1 foot. Like that's a definition of 1 foot. If I have 100 centimeters, I have 1 meter. 5,280 feet equals 1 mile. These things are all statements that are equal to each other. 1 inch is 2.54 centimeters. It doesn't matter. It can be anything as long as it ends up being equal to it. So sometimes you know them, like most people know 12 inches equal a foot. Sometimes you don't know them and you have to look them up. So in the event that you have to look it up, you just Google, hey Google, or hey Siri, what is the number of blah, 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 and something else, and it actually tells you. And so that's pretty cool. So conversion factors are equal statements. And in fact, today in the lesson, we'll have a little contest, a little activity where we're going to look at different conversion factors and what are equal to what. Because if you know conversion factors, so much of chemistry, when I think about it, it's just there's so much is going to be converting stuff and using this process of dimensional analysis. Okay, ready? Here goes. So this is a typical type of problem that you must solve in my class. And so good luck with that. All right, so here is the problem. It says, how many centimeters are in 3.2 yards? Okay, so this is a very important problem. So 3.2 yards. So where you start in these problems are you always start with whatever they give you. So they're going to be 3.2 yards. Okay, we're going to make what we call these little bridges. These should be straight lines, but it's hard to draw, so don't judge me. So what this works as is that if you use the conversion factors and set them up in such a way where the units can cancel out. So what causes a unit to cancel out? So if I have a 2x divided by an x, they end up canceling out, right, in math class. And it's the same thing with conversion factors. If I have 1 yard and that's equal to 3 feet, what actually happens is yards get canceled out. And now I can convert by feet by just multiplying them across. So if you're across the top, you're multiplying. If you're on the bottom, you're going to be dividing. Let's keep going though. So we're going to keep using these conversion factors until we get our desired unit. And so you keep adding conversion factors, keep setting up the problem until it's perfect. Okay, so then we know that 1 foot is equal to 12 inches. Do you remember that? Of course you do, because you're so smart. See how the units cancel out then? They actually, if you set them up right, the units do the work. And supposedly, and this is always my problem when I played golf, is like I wanted to kill the ball, but you're supposed to let the club do the work. In dimensional analysis, let the units do the work. So think about it. See, inches are here, and you have the conversion factor. You're going to put 1 inch right here, and then 2.54 centimeters right here. Inches will cancel out. Okay, then you're going to take your trusty calculator. Hopefully you have one. Okay, this year I can't give them out. I'm sorry. So there it is. Okay, so you're going to type in 3.2 times 3 times 12 times 2.54. And you're going to hit divided by the bottom. But in this case, since it's all ones, it's just super easy. You don't have to do it. And you get this giant number, well, it's not that giant, 292.608. And, we'll talk about rounding. The biggest thing is that you include units. Okay, so units are important. Okay, and let's just, for today, we haven't really gone over rounding rules. We'll just round to one decimal place. So 292.6 centimeters. Bingo. Okay, now, you're going to run into really big numbers in chemistry. And so when you run into really big numbers, we use something in chemistry called scientific notation. This is very common. Okay, so scientific notation has the form, m times 10 to some nth power. And what it does is it cleans up our numbers. It makes them nice and easy to work with. And so I highly recommend using this in your calculators and punching things in this way. So rather than write 3000, which is just like such a pain, you can write, okay, so what m is m is between 1 and 9.99999. So basically it's between 1 and 10, okay? And it should have, so you're going to move this decimal so that this number is between 1 and 10. So it's going to be 3 times 10, and then you have to figure out how many spots it took to move that decimal. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we would say 3 times 10 to the 10th is that number. So n is the number that moves the decimal point, right? And then m is the actual value of the number between 1 and 10. And so basically all we did was we just moved the decimal point, and so this is actually equal. Now in your calculator, there's a button. It's the EE button. It's right above the 7. It is typically read as that. And anytime you see E, that means times 10. So that's just a little tip when using your calculator to put in scientific notation, use that EE button. Okay, let's do this one. So this would be 2.4. Again, the m has to be between 1 and 9.999, right? Times 10, and then the decimal's here at the back. And so you have to figure out 1, 2, 3, 4, 5 spots over. So we would say to the 5th. Now, for big numbers, it's positive. N is positive. This guy's going to be positive right here. For small numbers like this, see how small that number is? It would be 3.4 times 10 to the negative 1, 2, 3, 4, negative 4th. It would be our answer. So I may pause the video if I'm feeling it and just do a couple examples real quick. But otherwise, you've had some of this before. This is just kind of review. Okay. All right, let's do one more problem and see where we're at, and then we'll kind of break off into groups. This is just so exciting. All right, so look at this one. So you're going to be doing a lot of metric prefixes, and you might end up with different ways of doing this. So this is done the same way. You're going to use these conversion factors in such a way to cancel stuff out. So here goes. So we have, if you take a look, 1.2 times 10 to the negative third kiloliters, and you're trying to figure out how many milliliters they have. So to ml. So you always start by writing out your initial value. And some people are like, Mr. Wood, I don't want to show work. And I'm like, too bad. If you don't show work, you go 0 points for this. So make sure you show work. Work is the most important part. And in fact, if you get it wrong but have the work, you're going to get most of the points. Okay, so that's good. So then I'm going to use these conversion factors. And initially, I'm going to give them to you. Eventually, you have to know these metric ones because you'll memorize the chart. So rather than write 1,000, sometimes we write 10 to the third. So I'm going to write this 10 to the, or let's see, in 1 kiloliter, see, you set it up so they cancel out. There's 10 to the third liters. Or if you want, you could write 1,000. Okay, so kiloliters would cancel out. And I keep converting until I get my desired unit, which is milliliter. So I'm going to go 1 liter and then 10 to the third milliliters, or again, I could write 1,000, doesn't matter. So now if I use exponents, when you multiply exponents, so you always multiply across the top and divide by the bottom. So you actually just add them. So I'm going to add negative 3 plus 6. So this is going to be 1.2 times 10 to the third milliliters is going to be my answer, or 1,200 milliliters would be the correct answer, because that's times 10 to the third. All right, it makes perfect sense, right? So we're going to practice a little bit, and then this is where the practice part of chemistry comes into play. So make sure you have your calculator. Make sure that you are able to punch it in, because no one wants to do all this math in their head, right? I mean, you can, but something to think about. Okay, we're going to pause this video, and we're going to do the rest of the lesson in class. Let's do this, folks.